Hi and welcome to Algebra 1. My name is Ingrid Throgmartin and I'll be explaining to you Unit 7, Section 3, More Multiplication Properties of Exponents. Now the rule is that if you have a base and it has a power of m and it's then raised to the power of n, then the rule is that you can multiply the exponents together. So for our first rule we have a raised to the power of m then raised to the power of n is a to the mn. So if I was to do an example of this, if I took 2 squared and I raised it to the power of 3, then I would have 2 raised to the power of 2 times 3, which is 2 to the 6th power. Now, if it's a number, we should be able to find it. If it's a variable, then we can leave it as the variable to that power. And 2 to the 6th power is 64. So if it's a number, make sure that you actually find that answer. Now, for the next example, we have a fraction, and we have a over b, so one number over another number, and we're going to raise that to the power of negative n. Now, the first thing we want to do is we want to use the rule where the reciprocal is makes the power positive. So what I'm going to do is I'm going to put a 1 underneath the a over b raised to the power of negative n, and I'm going to switch them out, and so I'm going to have the 1 on top in the numerator, and I'm going to have the a over b in the denominator. But instead of having a power of negative n, I'm going to make it positive n. Now, if you look at the next step here, what I'm going to do is I'm going to use the rule where we multiply the powers. Now, the a has a power of 1, and so does the b. Now, since they're both raised to the power of n, I'm going to multiply 1 times n to give me a to the n, and I'm going to multiply for the b. I'm going to multiply 1 times n, so it's b to the n as well. Now, this represents a complex fraction, and if we go up here, it's actually 1 divided by a to the n over b to the n. And if you remember your keep, change, flip rules, I'm going to keep the 1. I'm going to change the division sign to multiplication, and then I'm going to flip this back fraction again. A lot of flipping going on. So a b to the n over a to the n. So when I finally simplify this, I get b to the n over a to the n. So there's our final answer. And we could also take it one step further. I'm going to show you that in slide 3, and I'm going to show you how to take an answer like this and put it back so that it has one exponent. But for now, we'll go on to slide 2. Now, this slide's actually asking us to rewrite this with one exponent. So what I'm going to do is use parentheses. So before we were taking the parentheses and multiplying the exponents and actually removing the parentheses, and now I'm going to put them in. So you've got to think, what can I do with the m and the n so that I have parentheses? So let's put parentheses around the m to the n. Now, if you realize this, there's a 1 there in the exponent, and it's implied, so I call it an invisible 1. It's really there, but we don't normally put it in. So now you've got to think, what would I need to multiply 1 by to get a 7? Well, I'd need a 7, wouldn't I? So here's my first guess. I'm going to write m to the power of 1 raised to the power of 7 over n to the power of 1 raised to the power of 7. So really, I've succeeded in, I've only got the one exponent now. If I tidy this up a little bit, let me write the n in there. And since the 1 is implied, then I don't really need to write it, and I can just write to the power of 7. So, to write it with one exponent, all you need to do is put the parentheses in. Okay, for our final example, this is one of the harder ones that you'll see in at the back of the book in your assignments. So, here's what we're going to do. I'm going to rewrite the n to the power of x plus 2, and I'm going to keep, change, flips because it's a division. If I want to, I can take the division sign, and we all know that there's a 1. Again, it's implied, it's underneath the n to the x, but I'm going to flip that back fraction and make it 1 over n to the x. Now, if I use my fraction rules, I'm going to multiply straight across. So n to the x plus 2 times 1 is n to the x plus 2. It's the same thing, isn't it? And then underneath, if I multiply the denominators together, 1 times n to the x is n to the x. Now, you're probably going, how am I going to simplify this little thing? Well, here's what I'd like you to do. You now have to start to think backwards. Look at the n to the power of x plus 2. I can rewrite that as n to the x times n squared. Now, think about your exponent rules. Remember when you multiply the bases, you add the exponents? Well, now I'm just doing this backwards, aren't I? Now, I still have n to the x underneath. Okay, this is looking pretty good. Look what I've got in my fraction here. I have n to the x over top of another n to the x. Whenever you have multiplication and division, you can actually cancel these out. So these cancel out and then become 1s. So look what I've got now. I've got 1 times n squared over 1, which is n squared. Well, that's it for today. If you have any questions, make sure you start a discussion, and I'll get back to you as soon as I can. Thanks and bye.